data structures and algorithms using C. In this session, we will be dealing with the conversion of infix to postfix using a stack. So we have already done that. We know how to convert infix notation to postfix. Now we will look into the implementation of this program. So let us see. So in this lecture, you will learn the algorithm to convert a mathematical expression from infix to postfix using a stack. And we will implement it. That is what we are going to do. We are implementing the algorithm using C. And we will write, therefore, quite a number of these functions which will help us to convert infix notation to postfix notation using a stack. So we are getting into programming now using C. So one of the things is we will declare a constant called size to give the size of our stack, and we will limit it to 25. It is too high, but it's okay. We have kept it at 25. Then we are creating a new data type called stack. As you see here, type def struct stack type, and then here we have an array called operators, which will where we will push our operators onto the stack, and top will give us the total number of operators which are pushed onto the stack, that is needed for us to check whether the stack is full or stack is empty. Then we create a new variable called S of the stack type. So we have created a new data type here called stack, which contains an array of this size here and one more variable top, which gives us the information about the number of operators on the stack. So let us see, we'll carry on. Now these are the functions. Really, first of all, we have four functions which we are going to use: push, pop, stack empty, and init stack. You're already familiar with these functions, but just want to show you, after declaring that size, we are going to have these are the prototypes of the functions related to stack: push, pop, stack empty, and init stack. Then we have these two functions which are very specific to this program, that is conversion of infix notation to postfix. So we have the function here, prototype of the function infix to postfix. As you see, returns character pointer. In other words, it gives the starting address of the postfix expression which we are creating in this function, and precedence gives us the precedence of the operator. We plug in an operator here, plus it will give me the precedence of that, because precedence is very important to work on the operators while we do the conversion of infix notation to postfix notation. So again, we'll go through quickly the functions. Push operator. So first we check whether the stack is full, size -1. If top s dot top is size -1, then you say stack return, you don't proceed. Otherwise, what you do is increment the value of top and then insert that operator at that location. So this is the push function related to our stack. Next function is pop. So I've got a local variable called operator. So I want to pop an operator from the stack. So what do? First I check whether top is equal to 0. That means if it is equal to 0, it is going to be an empty stack. There are no operators at all, because we initialize the whole stack to 0 before we proceed with this problem. So if top is equal to 0, then I say stack is empty, return -1, otherwise else. So I get the operator from this array and then decrement the value of top, because we have removed one operator. So I decrement the value of top and then I say return operator. So therefore, as you see, pop int, it returns the operator, maybe plus or minus or into or power or any one of these. These are two important functions related to our stack. Then also there is one more function, stack empty. So then, so we know if the top is equal to 0, because this is how we are initializing the stack. If it is equal to 0, return 1. That means stack is empty. Otherwise, return 0. It is not empty. So this function in the next function init stack, we always need to initialize before we start the program in the main. First thing we do is we initialize the stack to 0. Of course, some programmers would initialize to -1 and start inserting or pushing data items from 0. So, but I have changed it. I made if top is equal to 0, I know that there are no operators. Otherwise, there are operators. So these are 4 important functions related to the stack. A simple example here. You have got this infix notation. So this is the precedence of these operators. As you see here, left parenthesis, as you know, goes onto the stack. A, that goes onto the postfix, plus here it goes onto the stack, and then B goes onto the postfix. Then you got the right parenthesis. So you pop the plus till you come to the left parenthesis. Now stack is empty. Incoming operator is power operator, goes onto the stack because stack is empty. Then 2, it goes onto the postfix, divided by, now precedence you have to check, precedence of power is more than precedence of divided by, as you see here, 5. Therefore that goes on to the postfix and you push the incoming operator onto the stack. Then you have got left parenthesis always goes onto the stack. C goes onto the postfix, and minus is there. Minus naturally goes on to the stack. D goes is inserted into the postfix. I get the right parenthesis. I pop that minus till I come to the left parenthesis. You are left with only divided by, and you have come to the end of the expression, and there is one operator is there. You pop that operator and stack becomes empty. So this is what this is how you have converted an infix notation into postfix notation. This is what we are going to do in the next session. In this session, we have just learnt about, again, we have gone through the stack and 4 of the functions which are needed for the conversion of infix notation to postfix notation. So we'll get into the next session where we will do the we go through the complete program about the conversion of infix to postfix. Thank you.